Hello, let's talk about some compound data type in Rust. And we're going to start off our discussion on the compound data types by talking about tuples. Okay, so I lifted off this test right from the Rust programming languages documentation online because I think it describes it very well. Okay, so it says a tuple groups values of different types into a single compound value, and tuples are constructed using parentheses, and each tuple itself is a value with a signature T1, T2, where T1 and T2 are, okay, so I have to remove this, so added types of its members, and functions can use tuples to return multiple values as well. So what this basically means is that a tuple provides a way for us to group individual items that are related in a way into a single value or a single variable, and it also provides a way by which we are able to access these individual items and also change them. Okay, so let me start off with an example. Let's say we are writing a program to we are doing something that has to do with 3D modeling, and so we want to store points in a 3D space. Okay, and you know that points in a 3D space usually comprise of the x component, the y component, and the z component. So the way we can use a tuple to represent this is, let's start off by creating a point. So our variable name is point, and then we can specify the data type. Let's just imagine that our point are float 32s. Okay, so I can say f32, f32, and f32. So basically what I'm saying is that this point is a single value that has three different items in it. And the first item is of type F32, the second is of type F32, the third is of type F32. Of course, you can even have, you can mix the data types, and the choice of the data type should depend on the purpose for which you are creating the tuple. But for this demonstration, I think F32 does it well because we want to be able to store X, Y, and Z coordinates that can have floating point numbers in them. So this is the data type here, and the brackets here is what makes it a tuple, and the fact that we have specified the data types for the individual items in there. That is what the documentation was mentioning here. So there's T1, T2, all the way to Tn. So you can have as many different data types as you want in a single tuple. And so once we have done this, the next thing we do is we actually assign values to it. So let's say, let's assume this point is at the origin. So the x is 0.0, the y is 0.0, and the z component is also 0.0. Now the question is, now we are aware that point is a tuple that has three items. The question therefore is, how do we access the individual items from the tuple? And the way you do that is you use the dot notation, and you use the index of the item that you are interested in accessing, and you start counting the indices from 0. So to access the first item, the index is 0, 1, and then 2 in that order. Okay, so let's say I want my x, so I'll say let x is equal to point dot 0. Okay, and I'm going to print my x component for you to see what's in there. So I'll say x, and then I'll come here and let's substitute x in place. So let's do cargo run and see the output. So you can see that the x, which is the first component, is accessible at index 0. In fact, to make things more interesting, I'm going to change this. I'm going to assign some proper values to them. So let's say this is 0.5, this is 1.5, and let's say this is 6.2. Okay, so let's recompile and run this program. And so you can see that our x component, which points to the item at index 0, has the value 0.5 because that is what is at index 0 in our tuple. Okay, so I'm going to do the same thing for the y component. And when I finish, I'll show you an easier way called destructuring, which will help us to avoid having to repeat these things. Okay, and I'm going to repeat this line as well. So this time around, I'm printing the y and I'm including the y over here. So let's run this program again, and you can see that indeed y points to the element at the index 1. And so, like I said, you use the point notation and you specify the index of the item that you want to access. So I'm going to copy this whole thing here, and then I will come down here and change this to z, and z is going to point to index 2, so z, and we use z here as well. So let's compile and run. So x is 0.5 and y is 1.5 and z is 6.2. So this is how you assess the individual items in a tuple. And of course, because we are storing the individual items in newer variables, remember that the let keyword is what declares a variable. So we have now stored whatever is at point 0 into another variable called x. Okay, so what if we want to print out the entire tuple? The way we do that is, first of all, let's try what you are thinking. So print ln, and I'm going to say entire tuple, put this one here, and I'm going to specify a point. And already the linter is complaining. What is it saying? It is saying cannot be formatted with the default formatter, and the help information is the trait stdfmt display is not implemented, blah blah blah. And because we have not learned about traits, this thing is going to confuse you a bit, but the simple explanation I can give you is that Rust has two traits, or many traits, but when it comes to formatting, the predominant ones are a trait called debug and a trait called display. And in case you are aware of interfaces in some other programming languages, traits are similar to the interface concept in other programming languages. And so for the formatter or the print macros to be able to print out even the primitive data types, Rust inherently implements these traits that makes it possible to be printed. So anytime you use these curly brackets to indicate a placeholder in your format string, basically what happens is Rust is going to call some function on the value that you want to substitute before it's able to print it out. Now, because a tuple is so flexible and can have different number of items in there, they took the decision to not implement the display trait. So the trait that helps this placeholder construct here to work is called display. So they did not implement that because they cannot possibly envision all the different types of tuples with a different combination of data types that people will be creating. So they left it out. And so the way you can display the entire tuple is to use a colon and a question mark. When we do this, we invoke another trait called debug, which has been implemented for the tuple data type. And so this is what we need to be able to properly print out our entire tuple. And by the way, if your tuple is too long, you will not be able to print it out. That is also a limitation that comes, but it's not too much problem, because for most of the programs that you written, you are not going to have to be using println to print out items from tuples. So this construct here helps you to print it helps Rust to invoke the debug traits on your value, and that is how the substitution is going to be done. Okay, all right, so now we know how to assess the individual items. The question is, how do we change the items? Okay, so let's say point now is 0.5 for x, 1.5 for y, and 6.2 for z. What if by some geometric operation, our y is now 4.5, and so we want to update our point to indicate that our y is 4.5. What we do here is to say point, and then we specify the index. The y is at index 1, and then we say is equal to 4.5. Now this is not going to work, and I'm sure by now you know why. And the reason is that in Rust, your variables are immutable by default. And so to make something mutable, you have to include the mut keyword. And now we will be able to print out point and verify that the y component has indeed been updated to 4.5. So you can see that in the second printing of the entire tuple, our y component has been updated to 4.5. So always remember, if you want to change individual items in your tuple, then you have to declare the tuple as mutable. Otherwise, you'll not be able to change it. And by the way, once you create a tuple, it cannot shrink or grow. What it means is that because we have declared that is a tuple of 3 F32s, there is no way we can declare a tuple of, let's say, 4 F32s. This is not valid. Okay. All right. So the next thing I want to show you is also called tuple destructuring. So you can see that when we wanted the X, Y, and Z component, we needed 3 different lines of code to be able to access them using the individual indices. Okay. Rust provides another better way, which is called destructuring. And the way we do destructuring is we say, let me remove this mute because for now we don't want to mutate it. So the way we do destructuring is we declare several variables in a go, but the structure of those variables should match the tuple that we want to destructure into. So I'll say X, Y, and Z, and we'll set it equal to point. Okay, so what we essentially doing here is that X is going to store the value of the first item in the tuple, Y is going to store the value of the second item in the tuple, and Z is going to store the third item in the tuple. And so now we can go ahead. I shouldn't have deleted my print statement, so we can go ahead and print them one by one. So I'll do print ln, and I'm going to do here X is equal to this, Y is equal to this, and Z is equal to this. Now I'm going to substitute them in place. So X, Y, Z, and this. Okay, so let's compile and see the output. So you can see that indeed the destructuring construct helps us to write more succinct code, or code that is shorter than the previous version where we needed 3 different lines to access the individual items. And in destructuring, we also don't have to specify the indices because it's the relationship between the variables on the left and the right is similar to what you do with the indices. So the first variable gets the first value, the second get the second, the third also get. So it's in corresponding order, and that is how destructuring is done. Okay, so now that we have done this destructuring, what if we want to be able to change the values that we have destructured into? Okay, so now we have destructured these into X, Y, and Z. And mind you, the X, Y, and Z are entirely different variables from point. They are just variables that happens to store the individual items of the tuple. And so if we want to be able to later change or mutate those individual items, then we have to assign the mutability property individually to the items. Okay, so I have now made the X variable mutable. So I can come here and say X is equal to, let's say, 89.90, and then I will come down here and let me copy and paste this code once again, and let's run it and see what happens. So you can see that now X is 89.9. Mind you, this X here, the changes that I've made to the X here doesn't actually affect the point. Remember that because of the let keyword, X, Y, and Z are entirely different variables that have just been initialized to store the individual items from the tuple. So to verify that, let's print the entire tuple once more. So I'll say entire tuple, and as you know, we have to use this, and then I'll say point in here. Let's run to validate what I told you. So you can see that when we print the entire tuple, even though the x that was obtained through the destructuring procedure was changed to 89.9, it doesn't really affect the point tuple itself. Okay, so this is it about tuples, and I also mentioned that functions can use tuples to return multiple values, as tuples can hold any number of values. And so let's create an example function. We haven't spoken of functions yet, but I will use it here, and you can always come back to this video when you watch the functions video if anything I say doesn't make sense to you. So I'm going to create a function called swap, and this function is going to basically just swap two values. So two values which are integers, so I'll take in x, which is i32, and I'll take in y, which is also i32. And what I want to return, this is how we indicate what we want to return. So I'm going to indicate that I'm going to return two i32s, and this is how we indicate that our function returns a tuple. You can see that this is the same structure that we use to construct tuples. And so what I'm going to do here is I'm just going to return a tuple that has y first and x next. Okay, so with this function created, I'm going to create a tuple here, and then we swap it. So I'll say let data is equal to let's say 10 and 20, and then I will say let result is equal to, then I'll call the swap function and pass in, I'm going to pass in data.0 and data.1. okay, and then I will print result. And because result is a tuple, we have to use this placeholder, and I'm going to put result over here. I think I forgot. Yeah. So let's compile this and run. So as you can see, the values I put into the swap function were 10, 20 in that order, but the result is 20 and 10 because of how I use the tuple here to swap them out. So that is it about tuples. Thank you very much for watching, and I will see you in the next video.